Alright, so the recording, I'll record, it'll be on a Google Drive. Once I create the file, I'll share the primary file across, so have access. And I should be able to keep it up about a year. Last year's, it's going to have to get deleted because my Google Drive's about full on that one. With 2 private pilots that are sitting there loaded up on it. We got, because I did one and Drew did one, so it was 24 hours of video on each one of those. So what we are going to do, we're going to go through the test prep book, front to back, go through the questions, try and do our best of looking at certain things, talk about it, answers, explaining. It's a great way to get through it. Sometimes it's hard to read it yourself and just go through and get everything out of it. The whole goal of the class, one of the purposes of the class is to prep you for the written, put you in a structured schedule for the written exam. If you follow with us along and then you keep studying at home, either going forward or back, but keep reviewing behind, keep that fresh. When we get done, we'll get the endorsement and go take your written. It's valid for 24 months, so hopefully you can initiate instrument training if you haven't already. You got too busy and still looking for, I don't know what's going to happen with the IWU. Well, Indianapolis never got anyone. Well, right now, everyone's flush with cash. There's so much, no one wants, in aviation, you don't need a university degree at all. So why pay, why deal with it? Like they said up there, everyone that shows up, they're like, I can pay cash and I don't have to do classwork. Yeah. All right, no problem. Same here, our 61's loaded. That's why I was asking you about it. We are signing up almost 2 new students a week, every week. And at least one of the 2 wants to be for a job. They want to fly all the time. So, that's why I wanted it, because no one had the cash. Now it's just weird. Great news, it's great to see. But yeah, I just sat with one. He's like, only 45,000 instead of 90 at ATP. He's like, I got that cash. Let's just get it started. Okay, let's go. Let's do it. He says ATP says they can do it in 5 months. I'm like, yeah, you can't even get a check ride. It takes 3 months just to get on a calendar for a check ride. So, but anyway, get that written out of the way, and then you can do your instrument. Instrument training is by far the most fun training out of all the different ones. With today's technology, you're going to learn. We're going to still have a big chapter in VOR work, but VORs, the Aero, we do 1 or 2 VOR approaches. I've got it marked as VOR and up. Brad loves that. They all hate doing VORs because they're hard to find, especially around here. VOR 4, VOR Alpha we have one. Henderson has one. Owensboro has 3. But Owensboro, it's hard to get theirs. I just tried to do it with Brandon, and in 45 minutes we still hadn't got. We were in a hole, just waiting for the opportunity to practice it because they still want to do it. GPS has ran over everything. Historically, 2010, we were supposed to have no VORs ever. The switch was going to be turned off. That never occurred. 2010 came and went. Then about 2015, we're going to go to 50. Only 50. That's it. We're going to leave 50 up in the air. We still have more than 50 operating. The big thing is they don't trust the Russians and the Chinese. They can hack anything. GPS, they're just concerned we can run is they got to keep a backbone. And that's what VOR is. We're just waiting for the FA to training side to catch up and just say, all right, they got rid of NDBs, let's just get rid of VORs. But unfortunately, with the equipment in the aircraft, you got to be tested on what's available. Because when we get to ILS and localizer approaches, they use the same equipment that a VOR does. It kind of stinks. You get stuck with VORs if you want to have those as well. I got smart. My OBS, the dial, it's digital. It hangs up. I love digital and I hate digital. Got love-hate relationship with them. We just seen an issue with the new AV30. We'd roll out level and they kept telling us we're going right. Just like my iPad, it locks up all the time. I'm like, I cannot. So frustrated with digital displays. Every single plane I've ever been in, delays. And I'm like, they can't do it right. But anyway.
So is there VOR questions on the test?
Oh yeah,
okay.
Lots of them.
Okay.
We're going to go through those. But from the actual check ride with, if we do it, I do all my instrument in the Aero. Just from best equipment, the rate isn't that much more. I mean, the total cost goes up like $900 doing it in that plane. You get your complex endorsement, you get your checkout done, all comboed in. If you are moving out of commercial, half of your commercial training's already done once you get 10 hours in the Aero. Because that's kind of what commercial is, 20 hours, 10 of it has to be complex, knocked out. So it's just piggybacking a bunch. But also one of the biggest perks that now I've seen, and like this is why I don't even want to do it in a Warrior, how many loops. It's so fast coming back around. We can get so many more approaches in, or like traffic patterns. IFR, you gotta go out 20 miles or so to get back in. In the Warrior, it just is slow. I mean, it doesn't matter, Warrior, 140s, 172s, any of those. The Aero, you just clean it up, 135 knots, you shoot straight back out. So if we're flying an hour and a half, we're getting a solid 4 approaches in, and the Warrior getting 2, maybe 3. Multiply that by a bunch of flights, you're doing a lot more in less time. So you actually are prepared in the minimum hours. I rarely have anyone really rush over the minimum hours, if they stay committed to it. Regular training, guys who start and finish, or I point at you just because you're here. Brandon's the same way. He was going good, and then we had a month and a half off, and I'm like, so then you just, yeah, not so much, because again, there is very little you're going to learn from the flight aspect. There is a VOR approach, which we'll do 1 or 2, but you basically have an ILS approach, a localized approach, and an RNAV. You have 3 things you learn. Now the downside is everyone's a little bit different with step down, so you got to be able to read the approach plate, but the steps are all the same. And then hold. I use Brad, love Brad as examiner. His hold is the start of an RNAV approach every time. The GPS tells you turn left now, turn right now. You just follow what the screen says. And all you gotta do is initiate. It'll even say, this will be a parallel entry. You don't even have to create your entry. It tells you what to do. So you just go in, you go half a loop, he's like, all right, let's go. And you leave right back out and come out. We will teach you, we'll spend 2 days on holds, but the fact is that it's super simple. It has autopilot. You have to do 1 partial panel without instruments. You basically lose your artificial horizon in DG. Nice thing with the autopilot, he said, again, he is like, whichever one you use the autopilot with is your 1 with autopilot, because you have to do 1 with autopilot. So you never use it until he covers the gauges and you go click, put the autopilot on, and away you go. And he expects you to do that. But we will do hand flying without it, just so you're prepared, because ask Chris Smith about. I didn't tell him to turn the autopilot off. He's like, hey, he's letting me use it. First approach, did the autopilot on the easiest approach you can do, and then got stuck without the autopilot the rest of the flight. So his partial panel was negative autopilot, which we have practiced way too much with the autopilot. So, but I just want to go through that stuff, get you set up on expectations with all of that. And you do not have to finish this class to start. We've started. I don't know what your plans are, but if you want to get started, let's just talk.
Well, I was going to say, would you recommend getting some cross-country hours in first? Because it's 50.
It's 50 hours PIC.
Which are close to 10 anyways.
Well, right, you get about 8 in your private pilot, so you got to get about 42 more. Just depends on how you're going to be flying. Especially doing this class, if you're flying with it, it will help you prepare for the written, because you're going to see the aspect of the training. Things will start to make some more sense. But that is the one thing that stalls some people out. If you're capable, finances and time is always a big thing, but it's kind of nice to do, try to do 2 lessons cross-country, 2 lessons cross-country. We will get almost 10 hours in your instrument training as well, which are PIC and instrument. So you can 8 to 10 we'll get within your training there. So yeah, I mean, that's how you want to plan it. The worst part is somebody, oh, I'll do that, and then they never go anywhere. And all of a sudden the instrument's done. I'm like, how many cross country hours you got? 13. Like, you need to go to Syson and eat a lot more.
And go check out all the restaurants.
Yeah. I will tell you, it's a lot easier to just take some big trips. So much easier to go to the Gulf Coast for the weekend. You figure, if you're gonna spend the money, why waste it flying up to breakfast and back 3 times? Just save your money and go to the coast. Pensacola is very easy. You've been there in Arrow, Destin.
Yes.
You down in
I
Arrow.
saw your pictures on Facebook.
Yeah.
That's pretty nice.
So, and the Arrow's nice, get you there quicker. But if you're building time, fly the slow plane. That way you get a little extra time and the same thing. And if you're smart, get some friends to go and make them split. Either split the cost, under table all the costs, make them pay the hotel and food or something to help you. That's why I flew all over the place. I went to Hilton Head for lunch one day when I was doing that.
Oh, wow.
Flew to Hilton Head, got up early, flew to Hilton Head, had lunch out there, loaded back up, flew home.
How long
So
did
great.
you be there?
I was in a Grumman Tiger. It was about 4.5 hours. Yeah, they're 130 knot airplanes, so as soon as the Arrow. Well, the Arrow's a little faster, but but that's the thing. It's the best way to build some flight time. Because if you're going to spend it's all about money. At the end of the day, you're still flying 40 hours. It's better just to save it and do it all in one big trip. Because it's a heck of a lot less boring. Because it is boring.
And you learn a lot too. Flying in, I said, and you learned a lot too, talking to military controllers and flying over restricted areas and being told to turn.
Yeah.
I don't know who did that.
That's why I don't even look at the route. I just get flight following and say, well, we'll file IFR. The worst part about IFR is you can't go in MOAs. But with VFR, you can go right through that MOA, even though they tell you can't. And I say, fine, cancel, I'll go on my own. Well, I guess just stay talking to you. Like when you go through. All right, so the first chapter in the 2022 book is weather. Looks like it's the same in your guys's. So we're going to get this ball rolling. Right answers at the bottom of the page. Easiest thing for preparing for this test, mark, highlight the right answer. So as you go back and review, you literally just read question, answer. Don't worry about the other ones, because if you read it question, answer, you're literally just reading it basically as a paragraph, and it triggers your memory quicker. As much as we need to know this information, the written's the written. The better the score you can get, the less you're going to have on your oral exam. So always shoot for that. And last thing before we really do this, Sporty Study Buddy has an app. Sporty Study Buddy is a flashcard app, really helpful. I think it's like $15. That's another way you can pick areas and you could say five questions, 10 questions, flashcard. What was it? Are you using the other one?
Yeah, and I left my phone home. Where I said,
What was that one?
I will have it at the next class.
There's another one that everyone likes to use. It's a website based, and it's a little bit more money. It's like $50. To me, it's the same concept as Sporties. You basically, it's raw memory. It's just flashcard after flashcard question, and then you either say the right answer or, in a time sheet. That's how they teach you. Everyone gets great. Golly, which one is that? They have it. They only do it for instrument and commercial. It's the only two they have it. But Sporties has it as well. It's the same concept. I kind of like Sporties because then you can take sample question or tests. You go, I want a 10-question quiz, and you can pick over one section or just give me 10, the whole thing. So like if you're sitting at lunch, it makes it, and it's right on your iPad or your iPhone, which is really nice. The other one's not as mobile friendly. So I know that's a downside of it. That's a very, very quick way. All right, so atmosphere. So one of the big things with atmosphere, and this goes out from, the equator, the troposphere, stratosphere, mesosphere, thermosphere, atmospheres and layers, or spheres characteristics. exhibited it in these layers. The troposphere is a layer from the surface to an average altitude about 7 miles, 37,000 feet. That's where most of our weather's being tied into, is within that zone. Out at the equator, it's going to get a little bit taller because it's warmer out that way. So it's about 20,000 feet over the poles, about 65,000 foot at the equator. It's higher in summer than winter. Again, so every single thing about our weather is heat exchange. You know, it's one of those concepts. Weather is, everything's created by the sun. No sun, no weather. No movement, no wind. Top of the troposphere is the tropopause, very thin layer making a boundary between the layers, characterized by an abrupt change in temperature lapse rate. Gets colder very quickly. Change there. Then, of course, like we said, the stratosphere is a layer, relatively small changes in temperature with height, except for warming trend near the top. Not just basic, simple part of that. And to make sure, you know, really, again, all of our weather's kind of with the temperature change and lapse rate staying within the troposphere. Up until recently, most planes weren't certified much above 37,000 feet. Now we're seeing all the small business jets. I think even the Lilly Eclipse is certified like 45,000. Things are going high. One day I was talking with Ryan Hobby, one of the examiners. Also, he's a really close friend of mine. I taught him his commercial and CFI. But he's a Southwest pilot, and we were saying once, and I texted him like, "Hey, that's a bad front line." I said, "I see a severe turbulence warning." I said, "That's a Citation jet, 44,000." He's like, "Yeah, those are those moron new pilots." He said, "That jet sitting, stall and cruises the exact same speed." He said, "That's why it's severe. Anything is severe because it immediately stalls if it's not smooth."
Wow.
It's a little Citation. He's like, because it took that high to even semi get over that. Like all the major airlines were blocked behind it. They were not getting through last year. And, you know, they're certifying these jets way up there because the pressurization system can now handle it. But, you know, it doesn't mean, you know, when you're, that's kind of your service ceiling, right? It's when your indicated speed equals, you know, as you're moving forward equals your stall speed. Because, you know, the higher you go, your true airspeed increases with the indicated airspeed falling off because the air's thinner. All right, so characteristic of the stratosphere. Okay. So it doesn't have a decrease. It's pretty stable in pressure or in temperatures. That'd be wrong. Even base altitude of approximately 35,000. Not even, right? The spheres change. So it's going to be C, relatively small changes in temperature with an increase in altitude. C. The average height of the troposphere. C, 37,000 feet average. Remember 20 to sometimes 55, 60. So 37 falls in. That one's easy. In my mind, is easy because that's just too low. And then which feature is associated with the tropopause? Abrupt change in temperature lapse rate or change rate, because that's again where the two flip. High altitude weather. The jet stream is a river of high speed winds, 50 knots or more. We're 187, like we see over at. I mean, what? I don't even know. I'm like, I am so glad I do what I do right now, not dealing with that. Because I've been watching, you know, you look at those pilot reports, and there's a lot of, the last week's been a lot of severe reports. I'm like, I just don't like that.
78,
Yeah.
150,
There's a
78.
real strong low pressure over the Hudson Bay up in Canada. It's just like pumping it.
Yeah, and I'm just like, what's causing it? I'm like, I have never seen it that high in 20 years. That's high. 110, 115, 170, 180. I'm like, that is nuts. In the winter, the jet stream will move south and increase in velocity. During the summer, it moves north and slows down. That's why summer months tend to be a little better for flying. We've been seeing, I know last March was terrible. It looks like we're already ramping up for a terrible March. I know this because spring break travel, when I normally fly, the weather sucks. And the winds in the last few years have just been out of control. So when I came home from spring break last year, last week of March. We climbed up to 11,000 feet because it was so rough. It was severe turbulence from 2,000 feet to 10,000. Everyone was flying a ton of ATP. I'm like, God, I wish I had the balls to just sit there and get ripped the whole time. K-Bear was, I could hear him on there like, is anyone getting caught? I've got 3 people with nosebleeds and head cuts. He's like, everybody's like, no. He's like, all right, I'll just stay here. It's getting shredded. Problem was, I was in a 135 knot airplane with a ground speed of 68. It was terrible. Oh yeah, it took well over 10 hours to get home. Over $2,000 just in gas, just to fly back from Orlando. It was horrible. And then when I got to Jabber, it was the same thing. I'd take that little thing. It looked like getting that little thing up at 9,000 feet. You just feel like you're going to fall out. And another 40 knot headwind, so it took us about 9 hours to get home from Tampa. It was just, ugh, my wife was screaming. All right, so a jet stream is defined as wind. This one's easy because you just pick, jet stream, just pick the fastest, 50 knots. You know, and that's even, most consistently our winds are 20 to 30, you know, much over 40, especially low altitude, you know that's going to be rough air. There's something going on to get it that low. I have been in 40, 50 knot winds that have been smooth as silk. A lot of times they are. Problem is when they're that great, when it is rough, it's always going to be ugly. Because, you know, if it just shifts a little bit or changes, that's a drastic amount of wind to shift around. I've had the arrow upside down and sheer, it's scared a little bit. And smooth air, smooth as can be. But we had a great tail, 68 knot tailwind. But when that wind, when we got in near just a wind shift, it was nasty. One wing just fell out and just rolled out on it. And we'd lost 3,800 feet till I got control of it again. So we were just watching movies. It was clear turbulence. So I don't even want that anymore. Like, my wife didn't fly in sun for a year and a half after that. It sucked. Didn't help us at night too, so didn't help us at night. And that was just, there's numerous planes in the area, so I got one little bump. I don't know what's happening, but it's just, I just happened to hit a shear where one was going this way, and it was much slower here, and instead of flying like this, I was in the tailwind, and then, like, just imagine a line like this, and just one wing gets over in that. So I immediately went from the tailwind to the positive, so it just got a ton of excess lift and just threw it instantaneously. And I will find it. If it's nasty, I will be there. Somehow I find all the holes. The strength and location of the jet stream is normally stronger and farther north in the winter. Yep. Weaker and farther north in the summer. Yes. So, B. All right, temperature. Major source of all weather is the sun. That's why gloomy days, unless it's a thunderstorm gloomy day, tend to be some of your best days to fly. So if you look at first solo pictures across my phone book, very few have the sun shining. It's almost always overcast. Those are the days we look for. You know, as you become an instrument pilot, you care a little less about the ceilings. You do look more for stratus clouds over cumulus. But it's always nice when you get that 10 and 12,000 foot overcast or even higher. Those are the days you want to travel. Some people are like, oh, I want the sun. I'm like, no sun. Give me a high, gloomy day. All right. In aviation, surface and loft temperature is measured in degrees Celsius. Standard temperature is 15. We should all know this by now. And the standard lapse rate is 2 degrees Celsius per 1,000 feet. That's what we call standard or average. Generally, if you look at it, it's never really that close. That's the average for considered standard conditions. All right, the primary cause of all changes in the Earth's weather is due to sun, right? Variation in solar energy received by the Earth's regions. I love how they just like to change words.
Right.
Like, what?
Just say exactly.
Yeah, I was just looking for the word sun. Solar energy, I'll take it. Okay. How much colder than standard temperature is a forecast the forecast temperature at 9,000 feet as indicated in the following excerpt with the winds, temperature aloft. So when we look at this one, it says the winds 070 at 37 knots with a temperature of -4, 6,000 feet is 100 degrees at 43 with a temperature of -10, right? So it says how much colder than standard temperature is the forecast temperature, okay? So for 9,000 feet as indicated. So at 9,000 feet standard would be 2 degrees Celsius per 1,000 feet, so -18 should be standard. And it's only -10, right? Okay, so should be about 7. We end up with, or I'm sorry, it should be about 8. We end up with 7. Because, God forbid, they actually give you the
They
real.
really consider it.
Yeah. And I like when it says, the temperature is -10, using the average lapse rate 2 degrees per thousand, the temperature change of sea level 9,018. Standard sea level temperature is 15 degrees Celsius subtracted. 18 from 15, you get 3 compared to the winds aloft. Oh yeah, I don't know why I started 0 to 15. See, it's been a long day working on airplanes. Standard temperature is 15, you go up to 19. You're at 18 degrees colder, so -3, -10, 7 degrees. There we go. Did I confuse anyone? Because I confused myself the first time. Started at 15, you dropped 18, took you to -3 as what it's supposed to be, and it is -10. So it is 7 degrees colder than standard. Alright, if the air temperature is 8 degrees at an elevation of 1350 and a standard lapse rate exists, what's the approximate freezing level? Finding freezing level is always important because of icing conditions. I will tell you, no matter what they say, if you're in the clouds below freezing, doesn't matter if it's -100 degrees Celsius, you get ice anymore. It just happens. We have the stickiest air ever. I have yet to be in below freezing clouds I didn't collect ice, ever, in the last 10 years. So that's the downside of doing instrument in the winter. If it's below freezing in the clouds, we almost can't do it. It's almost always icing. So if the air temperature is 8 degrees Celsius, okay, we need to get to the freezing level of 0. So we're going to need about, 4,000 feet? Okay, if we start at 1350, add 4,000 feet, it should be 5,350 feet. B, common type of ground or surface-based temperature inversion is that which is produced by, okay? Ground-based temperature inversion is going to be C. Ground radiation on clear, cool nights when the wind is light. Essentially, when you have warm ground, right, as the sun goes away, the ground tends to lose its heat, so it radiates the heat into the air, the hot warmth rises, okay, and then because the temperature of the ground keeps going down, the warm air is sucked out and it's ballooned up, but as the ground keeps getting colder, that warm goes up, but the air next to the ground is getting colder and colder because it's with the ground that's sucking up. The warm air is kind of getting caught, so you end up with, instead of getting colder all the way up, it all of a sudden gets warmer. It took me a little bit to understand. Like, I knew it, but I was like, how does that really work? Damn it. It's like, because if you just take the warm air, it's just going to sit over the ground. No, it's going to lift, and the ground's going to get colder because it's losing the warmth, which is going to cool the air that it just put the warm air in, and the warm air is going to get stuck above. Okay? So, like I said, you got ground radiation, cool nights when the wind is light. Why when the wind is light? The wind's blowing, it's just going to mix it up like a blender. Okay, the most frequent type of ground or surface-based temperature inversion is produced by the same question, right? A, radiation on a clear, relatively still night. What feature is associated with a temperature inversion? Stable layer of air. That's key. Stable layer. You see a temperature inversion, you get stable layer. The downside is if it's a pretty strong temperature inversion, what do you get after the stable air? Wind shear. Because you're gonna drastically, you got warm air coming up, then all of a sudden it's gonna flip to cold air, got to a wall basically and got stuck. So there's gonna be a wind shear, because basically gives you two layers. You got the stable air and then the atmosphere moving above it. So we get some wind shear. A temperature inversion will normally form only, okay, in stable air. Unstable air is what? It's moving, it's jumping around. It's not going to help us. Which weather conditions should be expected beneath a low level temperature inversion layer when the relative humidity is high? Okay, high humidity. We're still going to get the smooth air, but we're going to get poor visibility due to fog, haze, or low clouds. Okay, because the moisture's there to work with it. All right, wind. It's always there. Right. Air circulates in a clockwise direction around high pressure. Like the clock. High pressure cycles. Counterclockwise around low pressure. This is important because we can help identify where the wind's coming from. If you look at the big regional maps, see high pressure, low pressure. Okay, the closer isobars are together, the stronger the wind. Isobars are areas of like pressure. When they're very close together, that means the pressure is changing rapidly across, so wind is going to be increased. When you have a big gap between them, the wind velocity is going to be less because I just imagine it like pressure around something. When you have a bunch of pressure changes, that means that from out to in, there's a bigger change, so it's compressing it in, which is making it spin faster. If you have the same width, but there's a much less pressure difference, then it's not compressing as hard. It's probably not what's happening, but in a brain, it's the easiest way for me to process the information. I try to use not real, but ways to think about. If I was thinking about pressure and someone's pushing in on something, harder, it's going to make it go faster. All right, due to surface friction, up to about 2,000 feet GL, surface winds do not exactly parallel the isobars, but move outward from the center of high pressure towards low. Okay, so high pressure spins out, low pressure is pulling in from surface winds situation. So down low, it's going to move out. That's why we always say 3,000 foot winds. You got to be careful. You say, oh, I don't. 3,000 foot winds or 30 knots, I don't have to worry about that. In all honesty, you're going to have to, because at 400 to 500 feet, you're already coming up out of that surface friction. Now, it lists 2,000 feet, and yeah, sometimes it makes it, I've seen a pattern now be 38 knots, and then you get 3,000 feet, and they're back down to 12. But that's normally in a temperature inversion, because it's smooth, too. It's not even, you get that. Kind of the same thing. You got cold, dense air and warm air underneath. It's kind of getting trapped, so it tends to move a little rapidly as well sometimes. Okay, and Coriolis of force is at a right angle to wind direction and directly proportional to wind speed. The force deflects air to the right in the northern hemisphere. That's why the winds will veer slightly off, deflecting them to the right. I still haven't got a great, I understand the word where it's reacting. But that's also why your surface friction winds aren't good. Surface winds aren't going to line up because of that deflection as well. What causes surface winds to flow across the isobars at an angle rather than the parallel? Surface friction. Winds 5,000 feet AGL on a particular flight are southwesterly, while most of the surface winds are